Okay, as here we can see that in the last lecture we had verified the performance or the behavior of electromagnetic wave considering the electric field. Okay, we had considered the red vector as electromagnetic wave, and we had seen that whenever it is crossing a region from one medium into another medium, there are changes in the properties of behavior of waves, because for medium 1, here we can see that conductivity is sigma 1 epsilon 1 mu 1. In the similar way, for medium 2, parameters will be sigma 2 epsilon 2 mu 2 and so on. Whenever an electromagnetic wave is crossing its boundary, yes, in last lecture we had seen that boundary conditions can be split or can be divided into 4 different segments. We had seen these segments in last lecture. Just we are going to revise once again. Boundary conditions can be studied effectively by considering either electric fields or by considering the magnetic fields. In a very similar way, in case of electrical field, it can be subdivided into tangential components as well as normal components. In the similar way, whenever we are going to consider magnetic field, we have to consider tangential component as well as a normal component. So here also we can have a brief look or a short review on the structure. Tangential component are nothing but the components which are shown that are tangential, that is having or making an angle 0 degree with the surface of boundary, and normal components or the components in which the electromagnetic wave is passing perpendicular to the boundary of separation of two media. In a very similar way, in case of magnetic field also, there exist two components. One is a tangential component and another is a normal component. So it is the revision of last lecture. In the last lecture, we had considered this structure as medium 1 and medium 2, which is separated in this way, and we are considering ET1 and ET2 as components of electric field. As here we can see, we have started by consideration of electric field and we had planned for magnetic field in the next lecture. Here T is indicating tangential component and N will be denoting the normal component. Therefore, whenever medium 1 and medium 2 are separated by the black line as shown here, the ET1 and ET2 are the tangential component. We had applied Maxwell's equation to this, and a simple mathematics that we had completed in the last lecture was leading to the equation ET1 is equal to ET2. Friends, here we have to remember the behavior of electromagnetic wave rather than the mathematical routine. We can observe these equations later as they had completed in the last lecture. We'll directly reach to the conclusion which is required to continue for our today's lecture. That is, ET1 equal to ET2 was the equation we had derived in the last lecture. It was nothing but the case indicating that tangential component of electric field over a boundary are continuous. That is, if suppose ET1 is one tangential component and ET2 is another tangential component, then we can say that though they are crossing the boundary, ET1 will be equivalent to ET2. This was the last lecture's half component that we had completed. Then we had seen the normal component. So in case of normal component, we had seen that in case of electric field, considering the normal component, as here we can see that normal components are indicated perpendicular to the surface, but here we have indicated the volume instead of a plane surface, and the volume will be defined with the structure in front of you. It is composed of delta x, delta y, and delta z as the length. In parallel, please all of you have to remember that the delta x, delta y, and delta z are the components of the surface or the volume under consideration, which are the infinitesimally small values. That is, this box in front of you is very small, but for our consideration or understanding, we are trying to zooming it out so that it will be possible that we can understand the concept effectively. Then we had continued the mathematical part as here, that d bar dot ds bar as d bar dot ds bar, as all of we people are knowing that d bar is nothing but electric flux density. As it is a density, that's why we will have to consider the volume, and the volume will be composed of top surface, bottom surface, left surface, right surface, front surface, and back surface. What was the case for the tangential component? Over there we had considered the single ABCD type of loop, in which we had considered h bar dot dl bar a to b, b to c, c to d, and d to a, because over there we had considered the h bar component or electric field. It was related to intensity, and this is related to density. And for density we have defined the 6 integrals, but as here we can see that the normal components are considered, therefore the left, right, front, back, all 4 surfaces will be contributing to 0, because here we are going to consider only normal component, and the mathematical routine can be completed, and we could write dn1 minus dn2 is equal to rho s. Thus, conclusion of last lecture was normal components over a boundary are always discontinuous. For any electric field, if normal component are going to be considered, we can say that normal component will be discontinuous as seen in the equation present in front of us. Now we have to continue with, it was the revision of last lecture, though we have invested 10 to 15 minutes in the work of last lecture. Here we have to consider them as one of the important routines, because to compare or to have a proper understanding, we have to understand these equations effectively. So here I think now it is visible to you all. Just a minute. Yes, now we have to proceed further for the boundary conditions for magnetic fields. Though it is looking to be somewhat clear or somewhat difficult, but these are nothing but the very important parameter that are helping us to understand the behavior of electromagnetic waves. If electromagnetic wave properties are studied in a well manner, definitely this will be essential for the further understanding of properties of electromagnetic wave and performance of electromagnetic wave in different regions. That's why let us concentrate on the magnetic fields. In last lecture we had seen electric field. The diagram will be similar to the last lecture, but there is one change. Over there we had written ET1, here it is HT1. HT1 is nothing but magnetic field intensity for the surface ABCD, or for the loop ABCD, which is consisting of two medium uh, separated, having the properties or the conductivity sigma 1 sigma 2, having permittivity epsilon 1 epsilon 2, and permeability mu 1 mu 2. I would like to revise once again that in case of circuit theory, there is a value called as resistance. In case of field theory, there are two components, permittivity and permeability, out of which permittivity will be opposing to the electric field, and permeability denoted by mu will be the opposition considered due to magnetic field. Therefore, we can compare these two parameters or these two theories, that is electric field or the magnetic field, as a part of field theory, and it can be compared exactly similar to the, it can be considered exactly similar to the circuit theory, so that concept will be clearer. So here, as we know, Ampere's law can be considered H bar dot dl bar is equal to I. Now, as we know that H bar dot dl bar is consisting of path A to B, B to C, C to D, and again D to A, as per the last case. I think here you can understand in a faster way, because in last lecture we had started it in a very well manner. And new term that is in front of us is that k into delta x. Now what is this k into delta x that we have to understand? Here we can see that k can be defined as the current density per unit length. If suppose I is to be replaced with one new parameter, we can write k into delta x. Therefore, k into delta x is nothing but the, again it will be equivalent to the value I, but here for our simplification of equation, we are changing the value I into k into delta x. Okay, so it is again similar to the value of current, which is nothing but k is called as current density per unit length, and here as delta x is the length under consideration from A to B, as horizontal axis can be considered to be x axis. We can write further the equation like this. Here we know that as tangential components are considered, as per the last case, integration from B to C, which is vertical side, as well as integration from D to A, can be contributing to 0. As all of you people are knowing now that in case of tangential component, we are neglecting or we are keeping aside the normal component, and at the time of understanding the normal component, we will be keeping the tangential component aside. Therefore, if integration from B to C as well as integration from A to D is contributing equal to 0, we can write integration from A to B h bar dot dl bar plus integration C to D h bar dot dl bar is equal to k into delta x. As we know that h bar is nothing but the part of tangential component, as here can be seen, it is ht1 and ht2. We can write the equation ht1 delta x after simplification of integral, where delta x is the length. Once again, I would like to repeat why we are using delta x. It is the indication that these line segments or the line segments related to the horizontal and vertical components of the box or the surface or the loop are very smaller, and therefore it can be indicated by delta x or delta y. Therefore, integration A to B h bar dot dl bar will be contributing to ht1 delta x minus ht2 delta x is equal to k into delta x. I think there is requirement of minus ht1 delta x is required and plus ht2 delta x, but both of them will be giving the conclusion that difference of these two will be contributing to a value k, as delta x will get cancelled from both the sides. And therefore we can conclude the third part of our segment, that is tangential components of magnetic field are discontinuous. Why these components are discontinuous? Because the difference of ht1 minus ht2 is not equal to 0. It is equating to any constant value k, indicating that ht1 is not equal to ht2. If suppose the current flowing over the surface or current flowing through the loop is equal to 0, under that case only we can say that ht1 will be equal to ht2. It will be a specific case, but in general we can say that tangential components of magnetic fields are discontinuous. Now you may have some little bit confusion that in case of electric field tangential components were continuous. Here we have to remember that in case of magnetic field tangential components are discontinuous. Okay, it is exactly opposite to the electric field. Now reaching to the last structure of our topic today, magnetic fields, normal components. Here we have considered a box or the unit which is of very small length delta x, which is having very small breadth delta y, which is having very small length delta z, and bn1 and bn2 are the magnetic field normal components. So all of you people are knowing that Bn1 and Bn2 are nothing but the magnetic flux densities under consideration. Therefore, as per the last routine, we can equate the equation or we can consider the equation B bar dot ds bar is equal to 0. All of you people are knowing that it is one of the equation from a set of Maxwell's equation. Now here, as there is a volume, we have to write integration b bar dot ds bar is equal to composition of all 6 surfaces. It will be consisting of top surface, bottom surface, left, right, front as well as back. All 6 surfaces can be taken together, which can be equated to a value 0. So here, as we are considering the normal component, as per the previous derivation, we can observe that the integral b bar dot ds bar on the left integral, right integral, front as well as back integral equate to a value equal to 0. Therefore, we can write integration b bar dot ds bar over top surface and b bar dot ds bar over bottom surface is equal to 0. Rewriting the required equations of b bar on the top surface as bn1 and delta x into delta y are the surface values, as we know that delta x is the length and delta y is the breadth of surface bn1. In a very similar way, for the Bn2 magnetic flux density, we can write Bn2 into delta x delta y. Solving these integrals, we can write Bn1 minus Bn2 equal to 0, which will be equating the value of Bn1 equivalent to Bn2. That is, if suppose normal components of the magnetic fields are considered, these fields are assumed to be continuous, which were not continuous in case of electric field. That is, in case of electric field, tangential components were continuous and normal component were discontinuous, and in case of magnetic fields tangential component are discontinuous and magnetic, in case of magnetic field normal component, field components are continuous one. So to avoid the confusion, we can write the overall structure in this unit. I think it is visible to all, though it is somewhat blurred. It is readable. We can understand the comparison, or also you can remember these tables to derive all the equation. If suppose there is a question like explain the boundary condition for electromagnetic wave, under that case we have to define for electric field as well as for the magnetic field. We have to consider tangential component separate and again normal component separate. The conclusion of tangential components of electric field will be ET1 is equal to ET2. Intentionally they are shown by the green color, and normal components of magnetic field are Bn1 is equal to Bn2. Intentionally again they are shown with the green color, whereas the tangential component of magnetic field are discontinuous and normal components of the electric field are discontinuous, as we had seen in the derivation. Okay, intentionally they are shown by the red color. Red color can be indicated that similar to a traffic signal, we can observe that green is nothing but the indication of continuation, and red is the indication to stop. Stop is nothing but discontinuity, and green can be considered to be continuation. That is, equations are continuous for electric tangential component and normal magnetic component, but they are not continuous for uh, tangential magnetic component as well as normal electric component. Therefore, we can conclude our lecture that this table is describing the behavior of electromagnetic wave considering the properties of electric field and properties of magnetic field that are derived with the help of Maxwell's equation, that can be understood in a very well manner also by the practical sense, but we have to remember as per the equation provided to us, and we have to show it with the derivation part. So though it is completed by from my side, if there is any confusion, if there is any doubt, we can discuss so that concept will be more clear. If there is no any doubt, I will ask a few of you students to answer some questions. Therefore, let us start from your side. If there is any doubt or question, you can ask. We will ask the first question. 1 minute time for thinking over the issue. The chart is in front of you. Electric field, magnetic field, tangential component, and normal component. Rakesh is considering that one question will be asked to me. Therefore, I think he left, or by mistake he have left. He will come back. Okay. In the last bit, Lakshmi, or all the students that can pay attention here, what is the main concern in front of us is that we have to understand the behavior or properties of electromagnetic wave. We'll consider this concept from the top view. That is, if suppose we have to consider the performance of electromagnetic wave. Okay, as a technical student, let us consider that if suppose how electromagnetic wave will behave is to be analyzed, because if we have to use these waves for transfer of information signal, definitely a complete knowledge of these electromagnetic wave it will be very much important. For example, if suppose there is one student who is living at a remote location, that can be considered to be one medium, And if suppose he is coming to the college and is in the department routine. Is it the screen not visible to you? I think it is visible to all. Somebody have told show screen. Which bit, Lakshmi? First, okay. Is it this one? You can also unmute your mic and you can tell us. Okay. So here, as per the doubt by Lakshmi, we'll try to understand from the first component. Here we are going to consider a volume. Okay, and BN1 and BN2 are the electromagnetic wave components which are indicated to be of magnetic field and in a normal way. Normal wave means in a perpendicular way. We have to verify whether a wave which is having a equation or which is having notation BN2, it is passing through the boundary, and after passing out it is renamed as BN1. Though it is not clear, I have tried to show it with two different color. BN2 is indicated with the pink color and BN1 is indicated with the red color. Though it is not visible, try to understand. That is, wave is going to change its behavior partially. That we have to understand. That is similar to our behavior, as I was just telling to you all. Whenever we are at home, our behavior is somewhat different, and as we are in the classroom or in the department or in the college premises, our behavior will be somewhat different. Depending on these behavior, we can predict the properties of we all. For any interview, suppose you are going to appear for an interview, many of the organization are trying to observe you all by keeping different scenario in front of you. They will be asking you different type of questions. Some will be technical, some will be soft skill oriented. That is, they are trying to analyze your behavior, so that they are trying to check whether you are suitable for their company or their organization or not. Similar to that, here if suppose we have to understand the behavior of electromagnetic wave, we have to check how does electromagnetic wave behave whenever it is crossing the boundary. Now, some of you people may think that, sir, why we are not discussing something related to the behavior of electromagnetic in one specific medium? The answer to that question is, whenever electromagnetic wave is present in only one medium, there is no any change in its behavior, because it is having the same value of conductivity, it is having same value of permittivity, it is having same value of permeability. That is, it is having same value of sigma, it is having same value of epsilon, as well as same value of mu. Therefore, there is no any major change that can be considered. But here we can observe that whenever it is crossing a boundary, a considerable change in the electromagnetic wave can be seen. Any electromagnetic wave is consisting of electric component, magnetic component, and the direction of propagation of wave will be perpendicular to the electric field as well as a magnetic field, as we know. Therefore, for this structure, we have considered the integration b bar dot ds bar is equal to 0. Now, if you will ask from where this equation came into existence, answer to that question is that this question is taken from the equation from Maxwell. It is considering the whole volume. As the volume is considered and here ds bar is there, we will consider all six faces of the volume. All six faces of the volume will be comprised of top surface, bottom surface, left surface, right surface, front as well as back surface. Now, as we are going to consider the normal component, that is perpendicular component, that is coming from bottom and reaching to the top, only that component are considered. The surfaces along left, right, front and back sides will be equal to their integral 0. Therefore, there will be existence of only two integrals for the top as well as for the bottom, whose addition will be equal to 0 as per the RHS of equation. If we'll substitute the equation value b bar dot ds bar with the upper surface bn1 delta x delta y, because ds bar is nothing but surface, the surface of top side is delta x into delta y minus the bn2 delta x into delta y. Its integral can be considered equal to 0. And by solving the integral, all the delta x and delta y contributing to a unique value will be sent to the RHS side. Therefore, we can write bn1 minus bn2 equal to 0, because the integration delta x delta y for both the integrals will be giving us the same value, because the volume that we are going to consider will be having the same surface from upper side or same area type of surface for the bottom side. Therefore, as area is similar, it can be taken as a common part and can be sent to the right hand side so as to be equal to 0. Therefore, we can write bn1 minus bn2 equal to 0, indicating bn1 is equal to bn2. That was nothing but the part to be considered. I think it is clear now, and the chart here of conclusion will clarify the part as a summary. Now, if it is there is no any doubt or problem, I will ask one student in the class with one question. I think only one question can be asked, and if suppose anybody is answering,
सर
yes,
हॅलो
बोला.
सर ते टॉप किंवा बॉटम इक्वल टू झिरो लिहिलंय ते झिरोच का होतंय?
झिरो म्हणजे कसं आहे माहिती आहे का, तुम्हाला मॅक्सवेल्स इक्वेशन आठवत आहेत का? मॅक्सवेल्स इक्वेशन मध्ये आपण 4 इक्वेशन घेतले होते. ओके,
हा
त्या 4 इक्वेशन मध्ये एक इक्वेशन होतं डेल क्रॉस एच बार इज इक्वल टू जे बार प्लस डी बार डॉट. ओके,
हा सर
दुसरं इक्वेशन होतं डेल क्रॉस ई बार इज इक्वल टू मायनस बी बार डॉट. ओके, तिसरं इक्वेशन होतं डेल डॉट डी बार इज इक्वल टू रो व्ही. आणि चौथं इक्वेशन होतं बी बार डॉट डी एस बार इज इक्वल टू 0 और डेल डॉट बी बार इज इक्वल टू 0. त्या इक्वेशनचं मिनिंग काय आहे की ओव्हर अ क्लोज्ड surface that we are going to consider or for a given volume, the addition of all the magnetic field or magnetic flux densities is equal to 0. ह्याला एक अनालॉजी म्हणून मी तुम्हाला सांगतो की फॉर एक्झाम्पल तुम्हाला किर्चॉफ्स लॉ आठवत असेल, किर्चॉफ्स करंट लॉ, किर्चॉफ्स व्होल्टेज लॉ. त्याच्यामध्ये जर तुम्ही इक्वेशन जर आठवलं किर्चॉफ्स फर्स्ट लॉ म्हणूया फॉर एक्झाम्पल, एडिशन ऑफ ऑल करंट्स फ्लोईंग ऑर रिचिंग ॲट अ कनकरंट पॉइंट इक्वल टू 0. एकाच नोडच्या ठिकाणी आलेल्या सर्व करंटची व्हॅल्यू असणार आहे 0. In the similar way, if suppose all the voltage or the potential parameters are considered, that also was equal to 0 according to Kirchhoff's second law. Similar to that, here according to Maxwell's equation set and Maxwell's equation number 4, we can write integration b bar dot ds bar is also contributing to 0. Similar to we can say that energy law of energy conservation, energy can neither be created nor be destroyed. In a very similar manner, if magnetic field or magnetic flux density is reaching at a surface or reaching in a surface or a volume, definitely it will be going somewhere. There is no any loss or there is no any creation of magnetic field. Therefore, b bar dot ds bar can be taken equal to 0. That's why. Okay. Now tell me answer to only one question. Anybody can tell me why we have considered loop for one derivation and why we have considered box or volume for another derivation. That is, in case of tangential component, I had taken a loop, and in case of normal component, I have taken box or the volume. What is the reason? Who is Mr. Maxwell? Who is Miss Maxwell? Who will tell me? कोण सांगू शकेल बघा बरं. क्वेश्चन पुन्हा एकदा रिपीट करतो मी. एका डेरिव्हेशनसाठी मी सरफेस यूज केलेला आहे. फॉर एक्झाम्पल मी तुम्हाला व्हिज्युअलाइज पण करून दाखवेन. For one particular component, we have used, just a minute, hold. For one surface, we have used, just a minute. Here it is. Just a minute. For one derivation, I have used this ABCD as the loop, and for another, I am going to use box. What is the reason of loop and the box? That you have to tell me. Only one question. कोणी आहे का क्लासमध्ये मॅक्सवेल? Many students are there. Whether it is right or wrong doesn't matter. You can answer yourself so that it can be considered. I will repeat the question. एका डेरिव्हेशन साठी मी लूप वापरतोय आणि एका डेरिव्हेशन साठी व्हॉल्यूम म्हणजेच बॉक्स यूज करतोय. काय रिझन असेल त्याच्या मागं? कोण सांगू शकेल? सरिता सांगू शकेल, लक्ष्मी सांगू शकेल, प्रियंका, पूनम, प्रथम, समर्थ, नूतन. All students can tell me. अमरनाथ can tell us. अमरनाथ, yes, अमरनाथ तू विसरून गेला बघा. अमरनाथ दिसत नाही. अमरनाथ, काय रिझन असेल मित्रा? Why we are going to consider loop somewhere and box somewhere? Yes.
सर ते ट्रे हे झालं ना सर थोडं.
काय झाले?
म्हणजे इथं आपण मधी कट केल्यासारखं
हा, कट केलेलं जे आहे ना ते बाउंड्री आहे.
हा, ते बाउंड्री कंडिशन.
हा,
बाउंड्री असल्यामुळे.
हा,
बाउंड्री असल्यामुळे सर
नाही, बाउंड्री तर वर पण आहे की,
पण इथं सेंटर मध्ये झालं की
दोन्ही ठिकाणी सेंटरलाच आहे. Okay, anyone else?
सर हॉरिझॉन्टल आणि व्हर्टिकल साठी.
हॉरिझॉन्टल आणि नाही. अजून थोडा विचार करावा. आय थिंक आन्सर इज इन फ्रंट ऑफ यू. तुमच्या स्क्रीनवर आन्सर आहे. Or if it is not possible, think over it. Invest the full day. एका डेरिव्हेशन साठी मी लूप वापरतोय आणि दुसऱ्या पार्ट ऑफ डेरिव्हेशन साठी बॉक्स वापरतोय. काहीतरी त्याच्यामध्ये रिझन आहे. That you have to tell me. You can tell me on a personal level. You can tell me on the WhatsApp post. You can tell me on the chat box. You can call me, or you can tell us in the group. So that concept of all the students will be clear. It is the only intention. Nothing apart from that. So therefore, think over it. If it is possible, you can tell me. You can have a break of half an hour to continue with the next lecture. Let us stop here. I think it is sufficient for today's work, and we will meet in the next lecture. Thank you. Stay home, stay safe.